So in part 4 of section 1.7, we're going to do 3 more applications. And this is just to give you further examples of setting up those charts and organizing the information and writing the equations. So that's our concentration here, is how to set them up and write the equations. So example 6, a little different from what we've already seen, talks about alcohol solutions, or I'm sorry, it doesn't say alcohol, it just says solutions. How many liters of a 40% solution must be mixed with 10 liters of a 70% solution to get a 50% solution? So again, I'm mixing things together. It's a mixture problem. So our chart is going to be the amount. Now we'll really start abbreviating. We're going to have the rate, recognizing that the rate is the percentage. And then the final column is still the amount times the rate. We've got 2 solutions. I'm going to be kind of specific. So we have something that is weak. That's the 40% solution. I'm going to mix it with something that is strong. That's the 70% solution. And I'm going to end up with one in the middle as a total that's in the middle of the other 2 percentages. So that is really, really important. It doesn't matter whether you write the weak or strong first, but the one that is the percentage in the middle of the other 2 has to be on the total. So that's the only one that really matters. Otherwise, you're going to get negative answers, which make no sense. The other piece of information they give us is that we have 10 liters of that 70%, so this is 10. Okay, that's all they give us. What they didn't tell us and what we're looking for is how much of the weak solution we need, so that's going to be our X. This time, what we're going to recognize is that if you have X in one beaker and you have 10 liters in the other beaker, so literally, here's X, here's 10, and we're adding them together, and my total down here is going to be X plus 10, and hopefully that makes sense. It's different. Before we had the total and we had to do a subtraction up here. Well, this time we don't have the total, we can do the addition. We know to multiply across in this chart, so this is going to be 0.4x. This is going to be 0.7 times that 10, and this will be 0.5 times x plus 10. Yay! Okay, let's write our equation. So again, the equation comes from this one. We're going to add the first 2 rows to equal the third row. So you have 0.4 x plus 0.7 times 10 is equal to 0.5 times x plus 10. And we can solve that. Get rid of all those parentheses. 0.7 times 10 is just 7. 0.5 x and 0.5 times 10 is 5. So fairly easy one to solve. We'll move the x's to the right to keep them positive. By subtracting the 0.4, that gives me 0.1. I can move the 5 back across, subtracting in will give me 2, and then we'll divide. So 2 divided by 0.1 comes out to be 1. So X is how much of the weak solution we need, and these are in liters. So our answer to the question is that we need 20 liters of the 40% solution. So a different twist in terms of the numbers and how they went in, but still very doable using the chart to organize things. Okay, our next example, example 7. Talks about water being evaporated. So how much water must be evaporated from a 32 ounces of a 4% salt solution to make a 6% salt solution? Okay, well, we still got multiple percentages and we have an amount. This is still a mixture problem, but this time we're not mixing things together. What we're doing is letting something evaporate off. So in terms, I guess, of it, my picture won't be very good. But here you have water, you've got the salt solution. What you're going to do is let stuff evaporate off so that you end up with a smaller amount, right? I'll see how that works. So we have an amount. We have the percentages. Those are our rates. And again, in this case, they're percentages. We're going to do the amount times the rate. So we're going to modify the chart to fit what we need. Well, we know we're starting off with 32 ounces of a 4% salt solution. So we're starting off with a 4% solution, and we have 32 ounces. And this is where we're starting. So this is where we'll start. And what's going to happen is we're evaporating off. And what we're evaporating off is pure water, because water is what's evaporating. It's going to leave the salt behind. So we're going to subtract off water. Now, I don't know how much water, but it's what's evaporating off. And water has no salt in it, so it's a 0% solution. And let's make a little comment to itself, right? That water has no salt and is 0% salt. And that's the sneaky twist to this one. To make sure you recognize that. And when it's all said and done, we're going to end up with a 6% solution because we're taking water out of it. There's more salt in what's left. And what about the total down here? Well, I got a minus x sitting there. So this is going to be 32 minus x. And there's our chart filled in. Okay, now we can come in and write our equation. So we'll have the 0.04 times the 32. Now, I tend not to drag out my calculator until I've got the equation written. You can. If you want to multiply right there. 0 times x is still 0. 0.06 is going to get multiplied by that 32 minus x. Okay, now we'll write our equation. We're going to write it the same way. I do need to recognize that we're subtracting this so that the negatives make some sense to me. So I have the 0.04 times the 32 minus the 0 is equal to 0.06 times 32 minus x. And I'm going to erase this so it doesn't get messed up. Oh, we can solve that. 0.04 times 32 comes out to be 1.28. I'm going to drop the 0. I don't need it. 0.06 times 32 is 1.92 minus 0.06. I'll subtract the 1.92 from this side, and when you do that, you end up with a negative 0.64 equals a negative 0.06. So, okay, those negatives are going to divide out, and x comes out to be 10 point, and it's repeating sixes, so we're going to go to 6, 7. So the question is, we're going to evaporate off 10 2/3 ounce or 10.67 ounces. Must be evaporated. To create our 6% solution. So a different kind of problem, but it still fits the chart. We just had to modify the chart a little. One more, example 8. So example 8 reads the diagonal of a rectangle measures 10 inches. If the length is 2 inches more than the width, find the dimensions of the rectangle. So this is a geometry problem. It says rectangle, it says diagonal. This is a geometry problem. So let's come in and draw our rectangle. And we're talking about the diagonal, which is that distance. So if you're measuring a diagonal, it's from corner to a non-adjacent corner is the technical definition. There's our diagonal. We know that that diagonal is 10 inches, so we're going to label it. The other pieces of information they give me is the length is 2 inches more than the width. I'm going to be a little more descriptive this time. So I'm going to call this side W, and then this is 2 more than that. So there's width plus 2. And you should notice that you've got a nice little right triangle sitting in there. So we're going to use the Pythagorean theorem. And the Pythagorean theorem, which most people seem to remember, is that a squared plus b squared is equal to c squared. So a squared plus b squared equals c squared. The key here is that c is the hypotenuse. It's always the side that's opposite the 90 degrees, so it's the slanted side. It's also always the largest side. So for us, that c is that 10, which we're going to have to square. A doesn't matter which of these two you call a, so I'll just go with its the width first. So that would be w squared plus w plus 2 squared. So the first time in this section, exponents rear their head. This is a quadratic equation, which changes the approach. You still need to get rid of the parentheses. I'm going to FOIL that out. So a reminder, w plus 2 times w plus 2 is w squared. When I do the outside and the inside, I'll end up with a 4w, then plus 4 for last. So we have w squared plus 4w plus 4 is equal to 100. That's 10 squared. And because we have exponents, it's a quadratic, meaning an exponent of 2 is the largest exponent we see, we're going to set it equal to 0. So we're going to move everything over, combine like terms. So I have 2w squared at 4W. And when I bring the 100 over and subtract, I'm going to end up with 96. Now again, factoring is more efficient, and I'm after efficient students. I'm going to divide everything by 2, and I can do that because it's equal to 0. So I'm going to divide everything by 2. That's to make the factoring easier. So I have W squared plus 2W minus 48 is equal to 0. And there are factors of 48 that subtracted 2. That would be 6. So factors really nicely. W with an 8, W with a 6. Because we're looking for positive 2, we need a positive on the 8 and minus on the 6. Solving those, you're going to get a width of negative 8. Wait, it's a width. That can't work. That's no good. But we are going to get a width of 6. Yay! So our width is 6. We then know that 2 more than 6 is 8. So we now know the dimensions of our rectangle. So the width is 6, and I think we're in inches. And then the length is 6 plus 2, which is 8 inches. And there's a right triangle. Good luck.